This video will explain how to solve equations using graphs of other functions. In our last discussion, we solved two simultaneous equations in which one was a quadratic and the other one was a linear using the elimination, substitution, and graphical methods. In the substitution method, we saw that when two equations are simultaneous and represent the same variable, after we substituted y with the x squared in the second equation, the right side expressions, x squared and 2x minus 1, they became equal. So if we go backwards, if they became equal, they must have come from two separate equations representing y. Hence, if x squared is equal to 2x minus 1, it implies that before this step, x squared and 2x minus 1 were each equal to y, respectively. We will use this idea to solve equations using graphs of other functions. Let's say we are given the graph of the function y is equal to x squared plus 2x. Using this graph, we are going to solve some equations graphically, by drawing a straight line and finding their points of intersection, if there are any. Again, remember a while ago we said that if x squared is equal to 2x minus 1, it implies that before this step, x squared and 2x minus 1 were each equal to y, respectively. Take note that one function is already given, the y equals x squared plus 2x, and its graph is already provided and must be used. So, for the first equation to be solved, which is x squared plus 2x is equal to 0, the left side x squared plus 2x must be equal to y, and that the right side value 0 must be equal to y also. We can check back by substituting x squared plus 2x into the variable y in the second equation. We will get back the equation x squared plus 2x equals 0. So from these two equations, it was just like the solving simultaneous equations last time with one quadratic and one linear. The line y equals 0 must be drawn as instructed. Don't forget, the line y equals 0 is the x-axis. We will now draw the line y equals 0 on the given graph and look for where they intersect. In this case, at x equals -2 and at 0. Therefore, x is equal to -2 or x is 0. These x values would make sense because if we are going to solve x squared plus 2x equals 0 algebraically, we would factorize the x from both terms. It becomes x times x plus 2 equals 0. Each factor is equated to 0, hence x is equal to 0 and the other would be x is equal to minus 2. So this graphical method is nonetheless reliable and acceptable. Let us always be reminded that the function in graph already given is y equals x squared plus 2x, because we must manipulate our equation into such that the left side is the given function x squared plus 2x. So for letter B, the x squared and the plus 2x are already good, except that there is a minus 1 term. What should we do with this minus 1 term? Yes, we must get rid of it from the left side by adding a 1 on both sides of the equation. You can also say, transfer it to other side and it becomes plus 1. From here we can now say that the given function y equals x squared plus 2x must be intersected by y equal to 1. The line y equals 1 must be drawn and the points of intersection be estimated as accurate as possible by indicating the broken lines. Here, the x values of the intersection points are 0.4 and -2.4. Therefore, solving x squared plus 2x minus 1 equals 0 graphically, using the given graph of y equals x squared plus 2x and the line y equals 1, the x values are 0.4 and -2.4. And again, this makes sense because if we check by using the quadratic formula to solve x squared plus 2x minus 1 equals 0, the resulting values of x can be rounded to 0.4 and -2.4. Letter C. Let's solve the equation x squared plus 3x is equal to 0. Recall the function given for use, which is y is equal to x squared plus 2x. What we can do is split the 3x into 2x and an x, so our left side will become x squared plus 2x and the remaining x we can transfer to the other side by subtracting. And so we will have to draw the line y is equal to -x to find the x values at the intersection points. And the x values are -3 and 0. Study the remaining two equations and check out how the equations of the straight lines can be derived to solve these equations graphically and by using the given function y is equal to x squared plus 2x.
Hope we're not too broken. I know I'm not always strong, and I've been counting days to get away, to see you again, see you again. Been fighting ways to get away, to see you again.
Run free and dive into the sky. Hear the wind crying out its prayer. Why are we so ashamed to be alive? Break the chains and our freedom.